Hi, welcome to Mr. Techpathy Tutorials. This is part 3 of Linux device drivers. Before proceeding further, I strongly recommend you to watch part 1 and part 2 of Linux device drivers from Mr. Techpathy videos. In this tutorial, we'll learn about role of Linux kernel. So, let's start with our topic. This topic is chosen to understand the exact role played by the kernel to provide various services. In this part, I'll just brief about kernel roles. Eventually, we'll be discussing them in detail in upcoming parts. In a Linux system, several concurrent processes attend to different tasks. Each process asks for system resource like computing power, memory, network connectivity, or some other resources. Who will be serving these resources? Yes, it's the Linux kernel. As discussed earlier in part 2, kernel plays an important role in managing overall system activities. Kernel here is a big chunk of executable code in charge of handling all the requests. Although distinction between different kernel tasks is not always clearly marked, the kernel role can be split into following parts: process management, memory management, file system, device control, and networking. Before discussing these 5 parts, let's have a look at the diagram, where all the components are marked along with other kernel entities. As you can see from the diagram, these kernel roles fall under system call interface layer, acting as an interface between various kernel components and user space applications. System call interface layer is exposed to user application layer. User application uses the system call interface as a means to access particular hardware functionality through device drivers. To know more about system calls, user space and kernel space, please watch part 2 of Mr. Techpathy tutorials. With this figure as reference, let's discuss 5 parts of kernel roles in brief. First, let's talk about process management. As a part of process management, kernel is in charge of creating and destroying processes and handling input and output operation. Communication among different processes happens through various mechanisms called inter-process communication mechanisms. We'll discuss about various inter-process mechanisms like signals, pipes, shared memory in upcoming parts. In addition, the scheduler which controls how processors share the CPU is a part of process management. More generally, the kernel process management activity runs several processes on the CPU or multiple CPUs. Let's move on to memory management. Memory management looks at how the kernel manages physical memory. Memory is a major resource, and the policy used to deal with it is a critical one for system performance. The kernel builds up a virtual address space for all the processors on top of limited available resources. We'll be discussing about virtual address space in upcoming tutorials. The different parts of kernel interact with memory management subsystem through a set of function calls ranging from simple malloc or free pair to much more complex functionalities. Next topic is file systems. Almost everything in Linux can be treated as a file. Linux is heavily based on file system concept. The kernel builds a structured file system on top of unstructured hardware, and the resulting file concept is heavily used throughout the whole system. In addition, Linux also supports multiple file system types. That is, different ways of organizing data on the physical medium. For example, disk may be formatted with the Linux standard ext3 file systems or the commonly used FAT file systems or several others. Key point here to remember is almost everything in Linux can be treated as a file. Next, let's move on to this on our next topic, device control. Almost every system operation eventually maps to physical device. All device control operations are performed by the code that is specific to the device being addressed. Only the exception entities are processor, memory, and a very few other entities. What does this mean? It means in Linux every physical device is controlled by specific code called device drivers. The kernel must have embedded in it a device driver for every peripheral present on the system, from the hard disk drive to the keyboard and the tape drive. This aspect of kernel functions is our primary interest in this tutorial. Next, last but not the least, networking. What is the kernel role with respect to networking? Networking must be managed by the operating system because most network operations like asynchronous incoming packets are not specific to process. The packets must be collected, identified, and dispatched before a process takes care of them. The system is in charge of delivering data packets across program and network interfaces, and it must control the execution of programs according to their network activity. Additionally, all the routing and address resolution issues are implemented within the kernel. Networking services from the kernel is the one which helps the programmer to explore and access various devices by accessing them remotely. This is end of part 3 of Linux device drivers. Coming to the references, I would like to refer most popular and freely available book on internet. It's Linux Device Driver 3rd edition. The authors have chosen to make this book freely available under the Creative Commons Attribution Share Alike license version 2.0. I recommend you to buy or freely download this book online and refer it parallelly while watching Mr. Techpathy tutorials on Linux device drivers. If you are not clear on any topic discussed till now, please watch part 1 to part 3 couple of times without missing a single point. This will help in upcoming tutorials. We'll continue our next topic in Linux device driver part 4. Till then, stay tuned. Please feel free to comment and query. Don't forget to subscribe Mr. Techpathy videos in YouTube. Thanks for watching and goodbye for now.